Hello and welcome to part 4 of Dev Maths and Stats Refresher Course, Lecture 6. We look at some simple charts in Excel. You can make many sorts of charts. Scatter charts are very useful for the kind of analysis we do on these courses. Pie charts, bar charts, others are very similar. So what I normally do is, if I've got some data in my spreadsheet, I click somewhere where there is no data, because Excel will often try to guess what kind of data you want to do, and in my experience it makes a mess usually of doing that. So to be precise, I might click in G100, but really just click somewhere away from the data. So it doesn't have to be exact G100, but click down here somewhere so it's away from the data, and then on the menu ribbon at the top, go and click on Scatter Chart and select the simplest scatter chart, and it should give you a blank rectangle. Right click on that and choose Select Data, and then click on Add. So on the insert part here, a chart. Where's the scatter chart? Here's the scatter chart. I just go for the simplest one. There's various options, so you can have them joined up and so on. So you get a blank rectangle. That gives you full control over what's going to happen. Then you click on this, go for Add Data. Just gone. Oh, select data. Okay, select data. They changed the name. And then add. So select data first, then add. Okay, there we go. Okay, and then from here, what we're going to look at is the number of bags of concrete they have and how many fittings they have. So the way you tell Excel what you're going to use is you press this button here. Now, there are various ways you can do it, but the easiest way is to select with the mouse is to press that button, which I think means insert data. So X, and so this is the stuff that's going to go on the X-axis. So on the X-axis we want to have number of bags of concrete, I believe. So you click on that, and then you can either type in here, or it's usually just easier to select with the mouse. So let's have that lot. So, and then click this again when you're finished. Okay, then how many fittings on the Y-axis? So do the similar thing with the Y-axis data. Number of fittings. Starts at the top or the bottom, doesn't matter. So let's go this way. Okay. And I click OK and OK again. You should have charts somewhere. Yeah, okay, so there's our chart. Okay, so how would you describe the relationship between the number of concrete bags and the number of fittings each group has, and what explains this? So this is concrete bags, this is fittings, so I describe that as a very strong and clear, almost exact positive correlation. Whereas it seems that if you have 2 bags of concrete, then you're going to have roughly this number of fittings in this range, and so it goes up very tightly, because obviously you need so many fittings with each concrete bag. Each bag of concrete's a certain ratio, so it's quite technical. So that's a very strong positive correlation, because it's a piece of equipment you're putting together, so it's must be linked closely. Okay, one nice thing that makes Excel very good to use for this kind of quick looking for correlations between variables is that you don't have to keep making a new chart all the time. So I want now to go onto a scatter chart to compare the number of bags of concrete with the number of filters they construct. But rather than starting again, I can use the tip above, and what you do is you just, concrete bags, I want to compare it with the number of filters they make, which is here. So just grab hold of this, drag it down to there. Make sure you put it lined up like that. And there's the thing. Okay, right. So this is a very different sort of relationship. I mean, it seems that it's almost as though there's a very little sign of any correlation. It's almost as though there's one group where the more bags of concrete they're buying, the more filters they're making. Another group that just seems to be buying, the more bags you buy, the fewer filters you make. So there's no very clear correlation, except it seems that there's more variation. As you increase the number of bags of concrete, there's more variation in the number of filters created. Which you could call it something like heteroscedasticity, because the variation is increasing as you change the dependent variable. So you'll meet that term in econometrics. Do filters have any impact on household health? Okay, here we're cutting to the bits that are important. Are filters actually going to make any difference to household health? So I want a slightly more detailed, because it's child centers, okay. So that's the number of child visits to the clinic, wasn't it? Yeah. So I can have a news column S which shows the percentage fall in the days of child sickness for each group, and then use a scatter chart to address this question. So is there any effect that filters are having an impact on the percentage of children, or the percentage fall of child sickness? So have a pause of that. I'll try and insert something on here. So I want a percentage fall in this variable from here to here. So if I give you a name for it, sick fall percentage. So what you're looking for there is 100 times the difference. I suppose the fall is this minus this, and then as a percentage of what it started at, divided by what it started at. So it's the difference between them, and then what it started at. So that's for 79%. Okay. Before I go much further, I'll put a percentage in. I think maybe one decimal place. Oops. And then when I copy it down, that format of one decimal place will copy as well. Yeah. Okay, we've got some problems where there's zeros in there, because if it was 0 beforehand, 0, then there's been a 0% fall. So for now, there are ways you can cope with that, but let's just get rid of those for now. Otherwise they'll muck up the calculation. I think that's all then. Okay, so now we want to look at is there any correlation between the number of bags of concrete and this fall in sickness? So we can just do what we did before, go back to the scatter graph that exists, click on the series, and one already says concrete, so we just drag this down to the end. That's what we get. Okay. Yeah, so I think you'd say there's some sign of a moderate correlation, certainly a decrease in the variance, but then there's lots of reasons that could account for that. Could be they're wealthier, better off. People are tending to buy the filters, so it could be reverse causality involved. But there seems to be some sort of link between a bigger fall in sickness visits by children and more concrete bags being bought. So some indications of a positive impact. And then you might say, are there any other pairs of variables that could be related? So have a look. I mean, is there anything else there that you think would be related? Number of households and the percentage of sickness fall. Do the bigger groups do well, for example? So in that case, you might grab this x-axis variable, put it onto the households. There seems to be any clear evidence there. The dependency ratio. gosh, no, very little evidence of a pattern there. No relationship between the dependency ratio and the fall in child sickness. Any relationship between sales, or no, profits and the fall in sickness. Possibly some of the high ones with the ones that are making more profits tended to have a bigger fall in sickness, but down here not much pattern. Okay, so you can explore the data see very quickly and tell yourself a story about possible impacts between these variables just by dragging the columns from place to place. So let me not spend too much time on that. Okay, good. So the next section, the next short video, then we'll look at the idea of filtering data. But for now, thanks for watching.